All right, welcome everybody. Today is day 5,244 of the COVID crisis. We are just now attending the Dallas Personal Robotics Group special presentation together with Hackster DFW. Today, in our normally it's the DPRG meeting, monthly meeting, we have fun presentations from all kinds of people. But today, thanks to Hackster, we have a presentation by Lou Amadio from Microsoft Edge Robotics. So once again, my name is Carl Ott, current president of DPRG, and wherever you're tuning into, whether it's from here at Dallas Personal Robotics Group headquarters, remote in Pittsburgh, Pennsylvania, my parents' home, or Dallas, where most of our members are, or in some cases New Zealand or Washington State, we welcome you. And well, so today after the presentation by Lou, we'll see it and discuss on that as long as it makes sense. And if anyone's still interested, we can continue on with questions and project discussions and stump the club challenges if you have any. So with that, I'd like to pass things over to you, Lou. So if you please feel comfortable just sharing your screen. And for housekeeping, everyone, remember you've got the chat on the right, top right of your Meet. So feel free to pop questions in, comments and such, and we can just proceed as makes sense.
You want us to mute our mics?
Yeah, if you don't and you make noise, I will mute you, and then you'll have to unmute yourself. So, all good. Okay, thanks everybody. Lou, the floor is yours.
Hello, everyone. Can you see my screen? Oh, fantastic. Can everyone see my screen?
Looks good.
Yes, I think so. Excellent. Thank you very much for inviting me to your Robotics Club meeting. My name is Lou Amadio. I'm a development lead at Microsoft. My larger group is the Edge Operating Systems team within the Core Operating System and Intelligent Edge group. My particular expertise is actually on graphics and robotics, and they surprisingly overlap. I'm going to be monitoring the chat window here, and I'll pause at each slide to let anybody ask any questions as we go. Okay, so let's begin. So the Edge Robotics mission is to accelerate development, deployment, and management of robots with Windows, Linux, and Azure. A lot of our work happens to be on Windows, but we also support Linux and cloud connectivity. When we talk about Edge Robotics, what we're really talking about is the robot up to the cloud, not necessarily the cloud down to the robot. And that'll become apparent on why that is as we go through the presentation. Can everyone, can I get a thumbs up to make sure that I'm being heard?
Yes, makes sense. Sounds good.
Awesome. Okay, fantastic. Okay, so our current focus is actually on the robot operating system. The robot operating system is a system for operating robots that it's an open source platform that allows you to build complex robots with emergent behaviors. It's really cool. It's also incredibly difficult to get started. There's a really high ramp curve to get to really leverage it. Honestly, I've started trying to use ROS about 6 times before I just said, you know what, I'm going to go do something else, whether I use Johnny 5 or Cylon or something else. But once you kind of buy into ROS, it really does make complex emergent behaviors, if not easy, at least attainable. And I'll explain why in a second. In the next slide. So what is ROS, or what is the core principle behind ROS? ROS treats individual nodes or independent solutions as, it breaks down the robot behavior into a bunch of independent nodes. A node is basically just an executable that can generate data or consume data. Now, when in a robot, you have multiple different sensors that are generating data at different rates. So how do you consume all of that data and do something interesting with it? Some sensors are really good at some things, like a camera is really good about giving you RGB data, where a depth camera will give you kind of an impression of the environment. But they often operate at different frame rates that you need to fuse them together. So that's really the core principle behind ROS, is that you can handle data being generated at different rates, fuse them together, and then do something interesting with it, and then send it down the pipeline. In this video, or in this presentation, or sorry, in this slide, what we're going to do is we're going to walk through a demo that we did for ROSCon 2018, which is a Turtlebot, a very basic differential drive robot that turned towards a person. You know, if you were to do this with Python or something, it'd be kind of easy because, you know, there's not really many different states that you need to do. But what this shows is that by buying into ROS, you can start adding behaviors over time and increase the capabilities of your robot. So for this particular demo, we used a hobby-grade LiDAR, a camera node, and then we built a machine learning node that consumes an Onnx model, and we'll talk about Onnx in a little bit. We had a node that took that information, all of that sensor data, and then turned it into a motion that we sent off to the hardware itself over a serial port. And essentially on the other end, it's just an Arduino. So we have sensors, we have compute, and we have output. So each one of these blocks runs in a different process. And one of the cool things about ROS is that these processes don't all have to be on the same system. You can actually just split these processing over multiple different computers, different compute units, either on the same physical robot, or you can actually have a desktop machine that processes the data for something else. And that's actually pretty cool if you have small robots that don't have a lot of processing power. I've seen little tiny drones about the size of a business card that actually do complex swarming behaviors because there is a desktop machine that drives it. So how does it work? Well, on startup, each one of these executables is given some parameters. It says, I want you to bind to this port, this COM port. Oh, that happens to be LiDAR, this particular camera, or this file, which in the case of WinML Tracker represents a machine learning model. They start then publishing data. And what does that mean? Well, the way ROS works is that it has what's called a topic, which is kind of like a named message queue. So you can subscribe to a topic and get blocks of data, or you can publish to that same topic. And you can actually have multiple publishers and multiple subscribers. And this is the principle behind PubSub. In the case of LiDAR, it is publishing a standardized message called laser scan. If you have a cheap hobby-grade LiDAR and an expensive safety-rated SICK LiDAR, they actually publish the same message. So you can swap out pieces of your robot without changing a lot of downstream work. That's really cool, actually. So in this case, the LiDAR is publishing on the scan topic, and the camera is publishing on a camera node. Doesn't matter what camera you have, the camera node is always getting that image raw. Now you might be curious, well, what happens if I have multiple cameras? Well, each camera can be assigned a namespace. Same thing with LiDAR. You can namespace each LiDAR. What you do with it is kind of outside the scope of this conversation, but know that you can do that. So in this case, we have a LiDAR and a camera publishing to different topics. And then we have listeners who take that data, fuse it together, and generate new information. So in the case of our machine learning ROS node, it creates a tracking object, which is basically just a pose of something it discovered in space. And then our node consumes those two pieces of information and generates a command to drive the robot. So it looks like a complex flow for a relatively simple operation, but that same flow can be used for a lot of different things. So similarly, we did a robot arm that used that same machine learning ROS node, but a different camera. This one happened to have depth.
Cool.
Okay, so same thing. We can publish point cloud, we can publish image data, we can listen to it, generate tracked objects, and then we have a executable that consumed all of that data and said, oh, I know what I want to pick up. Let me call a different subsystem ROS called MoveIt. We'll talk about what MoveIt is in a second. MoveIt is a gigantic subsystem for free space planning. So it does a lot of really cool things around understanding what space looks like and creating motion plans for robot arms. We happen to have a universal robot UR3, but pretty much a lot of different robot arms have ROS nodes, whether it's inexpensive U arms from U factory. We actually have a arm that we bought from Amazon from, what was it called? Anyway, it's a $200 servo-based robot arm that we were able to make work with MoveIt, and we actually have to open source that code. It's currently it was done by an intern. We have to clean it up a bit, but you can use hobby grade servo arms with this complex free space planner to do some really cool things with machine learning and environmental understanding, and take that hobby grade robot arm and run it on a $10,000 robot arm. So the same subsystems enable those scenarios. So in this case, we use the MoveIt subsystem to create a plan for the universal robot arm. We get information back about the state of that robot arm, and then we can do something like close a gripper. So we know when the arm is moving, we know how to control the gripper, and then we can move things around. So that's ROS in a nutshell. Any questions so far? I don't see anything in the chat window, so feel free to post here. I will check on every slide. So ROS 1 is what people think of when they think ROS. It was started in 2007 by Open Robotics. At the time, it was called Willow Garage. Now it's called Open Robotics after it went through a couple of acquisitions and spin-offs. At the time, Microsoft was building something called Microsoft Robot Studio that was kind of a direct competitor to ROS. They both share the same programming model. So if you've ever played with Microsoft Robot Studio, it's almost the same thing as ROS. Now, Microsoft stopped working on Robot Studio in about 2012. And there's a whole story about what happened with that. I happened to have been a dev lead at the time on the Robot Studio team, and followed through a couple of first-party robots when we shut that down. At the time, ROS originally was designed as a cross-platform system, but slowly the Windows code base kind of started to rot as it wasn't actively invested in. So in 2018, my team actually went and resurrected the code and made it work. And now Microsoft stands behind it and says we support both ROS 1 and ROS 2. So what's the difference between ROS 1 and ROS 2? Well, ROS 1 is mature. It's been around for about 10 years. Unfortunately, it's built on some end-of-life technologies. For example, Python 2.7, and kind of in a mix of old C++ and new C++. The cool thing about it is there are thousands of nodes representing different types of devices, different types of compute, different types of actuation. And you can find old robots that have ROS nodes. Now, if you remember from the previous slides, you can take any kind of actuator, whether it's a 30-year-old robot and modern sensor tech, and have that robot work. In fact, one of my side projects is resurrecting a Hero 1 from the 80s and making it ROS enabled. So I'll be writing that up on my blog and maybe do some YouTube videos on that. But my goal is to take this I guess at this point it's a 40-year-old robot, and give it modern behaviors using modern sensor technology. It does do pub sub, but it actually is a custom centralized pub sub. You have a ROS core, which kind of represents it's like the discovery mechanism. So everybody needs to know, every node that starts needs to register itself with that central location. And that can actually cause problems in a decentralized robotic solution. There is some security in it, but it wasn't designed to be a secure pub subsystem. Okay, so that's really ROS 1. Lots of great behavior, lots of tooling, lots of documentation, lots of online support. But it really isn't enterprise grade. It really isn't, it's built on some end-of-life technology. So what is ROS 2? Well, ROS 2 was really built as a redesign of ROS. Still built on pub sub, but it really is trying to take that code base to the next level. Introducing things like real-time support, introducing military-grade security, introducing enterprise-grade supportability. And that said, it's a new code base, and there are things that are just not ready yet. For example, the next generation motion control is still being brought up. In fact, my team is helping to do the bring up. The next generation navigation system kind of works, but the behaviors of the robots are not well defined right now, so they can get stuck really easily compared to the same scenarios on ROS 1. We are actively working on both. Now, I really am bullish on the next generation ROS 2, and I've said that ROS 2 is like Arduino in 3D printing. It's going to catalyze the maker moment for robotics, and I think this is going to be awesome when it's ready. And that's the important thing, when it's ready. It's not quite ready yet. So I'm going to switch over because that was kind of a big slide.
That's pretty cool. And there's a handful of questions that snuck in on there for you.
Sounds good. What do you think of WowE Robot work with ROS 1? Love it. There's actually a lot of companies that even iRobot uses ROS internally. We've partnered with mostly on the industrial side, and we'll talk about why a little bit when we talk about Windows. But there's, my buddy Stuart has a Nerf robot, one of those crab robots that's ROS enabled. It's pretty fun. Is it anything related to kids for attending robot? So ROS is, I would consider ROS to be like college level. High school it's a little ethereal for high school. One of the things that we're trying to do is make it easier to program ROS, like the whole community is. And I think that when ROS 2 is in better shape, it will be the Arduino. And that's when I think it'll be really appropriate for high school, and then even in elementary schools. One of the side projects we have is with the Microsoft MakeCode team, which is about building and connecting MakeCode. It's like a block level programming model with the robots. And you can drive them around and have interrupts that say, I've detected a person, let me do something. So that'll be pretty neat. It is a background project, so anyway, it is a background project. So it seems that ROS provides an excellent adaptation layer, the ability to use de facto standards. Yeah, ROS has become a de facto standard, and ROS 2 really elevates that to another level. The many different companies are providing solutions for ROS. I mentioned SICK and RP LiDAR, hobby grade and industrial grade solutions. We have hobby grade robot arms like the U-arm and industrial grade robot arms like KUKAs and ABBs. So there are solutions out there for different sensors, compute, and actuation. Now, when it comes to what works on Windows and what doesn't, we'll talk about that in a moment. But that's really kind of the biggest thing, is how hard is it to support it in the environment that you want to work in. ROS tends to be college level. Learning curve is a bit steep for younger students. How soon to ROS 2? ROS 2 is available today. ROS 2 navigation can be used today. We have some documentation. Actually, I'll just post the link. So if you go to, I actually have this at the end of our, so here's 2 quick links. Our ROS landing page shows all of the Microsoft support, and then we have documentation. It really is targeted towards industrial and commercial. We are trying to onboard more maker and educational content. How does ROS compare to MQ? Is this MQTT? MQTT tends to have smaller messaging. So sending a camera frame, for example, or LiDAR data is really outside the scope of MQTT or even AMPQ. So the messaging in ROS is designed to be more real-time, larger data blocks, more distributed, peer-to-peer, as opposed to more centralized in ROS 2. I guess in ROS 2 it's more peer-to-peer than centralized. How soon will it be feature parity with ROS 1 versus ROS 2? Open Robotics says that the core of ROS 2 is feature parity with ROS 1. But the subsystems on top are the things that are being brought up. My suspicion is within the next 6 months, the difference between ROS 1 and ROS 2 will be less at the infrastructure perspective. And then it's really about the number of nodes that are built on top of it. Because it really is about the ecosystem, and the ecosystem is still bootstrapping ROS 2. For example, from a mobile platform perspective, I only know of one mobile robot that has a ROS 2 interface to it, and that's the TurtleBot. Can ROS 1 modules be ported to ROS 2? Yes, actually. One of the things that to bootstrap the ROS 2 ecosystem is what they call the ROS bridge, which allows ROS 1 and ROS 2 to cross-publish to each other. Anecdotally, I've heard that that ends up causing a lot of problems, so I'm not sure where the benefit lay there, but there is a solution for it. ROS 1 nodes can be ported to ROS 2, and that's actually one of the things that my team is doing, is porting all of our first-party ROS nodes to ROS 2. All of our first-party nodes, when they can be, support Windows and Linux, so that you can choose whatever nodes and operating system you'd like to use infrastructure from Microsoft. Is it just a pub subsystem, or does it make things really tailored to robots? ROS Pub Sub is what enables a lot of the more advanced features of robotics. So for example, there is a spatial subsystem that is on top of ROS, or on top of the pub subsystem, that allows you to create a virtual robot and transform data from the sensors to the actuator, so that you can do things like, where is this object relative to the gripper of the robot? So there are subsystems. There's a lot of diagnostic tools and simulators available. Is there a port to Pi 4? Yes, there is. Pi 4 is supported by ROS. And in fact, one of the docs that I need to write is how to use our development environment with a Pi 4. It's not trivial to port a ROS 1 node to ROS 2. There's some fundamental differences in the messaging format, the messaging style, the API itself. So it is an activity. If it takes you a day to bring up a net new ROS node, it probably would take 2 hours to, maybe an hour to port it to ROS 1. So some of our more simple nodes, it probably will take 2 or 3 days to get them into ROS 2. And that also considers all of the continuous integration, continuous deployment, and continuous simulation that we want to enable at the same time. So, it's probably 3 or 4 days per ROS node. ROS 2 core stuff on Pi 4 now. Awesome. One other thing, I'll continue with the presentation. I love the conversation here. We have some stuff that I wanted to cover, and then we'll talk about some things that are appropriate for robots on Pi 4 and some of the other systems we have for you. Okay, so what are the core principles of ROS at Microsoft? Well, one of our goals or core principles is that we wanted to minimize the differences between Linux and Windows. If you like Linux, use Linux. If you like Windows, you should feel comfortable using ROS on Windows. We want to make it so that the ROS nodes themselves typically have a large dependency tree. So we provide solutions for dependency management so that you can use ROS 1, you can have your nodes work on Linux and Windows. One of the things we've done is development tooling. Not just DevOps, but also dev tools, for example, our ROS extension for Visual Studio Code, enterprise-grade solutions, key partners, and bridges to other Microsoft technologies. Okay, so let's see. Win 10 on a Pi 4 ain't really happening at the moment. That is true. Windows 10 one of my previous projects was Windows 10 IoT Core, which we supported on Raspberry Pi up to 3. When the Raspberry Pi 4 was a kind of a radical change, and there was a lot of proprietary components where we couldn't enable the drivers for. So it was a non-starter for Microsoft to support the Pi 4 with Windows 10. So, yep. But our development tools and our ROS nodes work on Linux, so that should be a benefit. Yep, no BSP for Pi 4. I'm actually really bummed about that because, but yeah, it was going to be a really expensive operation. So Windows 10 IoT is really designed for enterprise class devices, and this is where a lot of our investment has been, is on the commercial and industrial side. I'm going to blow past this because I think we, let's see, what am I doing on time? I'm doing okay. We've had installs of ROS on Windows all over the world, tens of thousands of installs per month. Really great to see. We are collecting this data using GDPR compliant solutions on the back end, so we kind of know generally where people are, but not specifically. So I just thought this was a fun slide that shows a lot of people really are really like using ROS on Windows. So what do we have supported? So we announced that we were working on ROS on Windows at ROSCon 2018. The response was actually phenomenal. I remember we had a small booth. I mean, the table was only 16 inches wide, so like having a robot turn was kind of a stretch. We had somebody come up to us and say, "Are you really supporting ROS on Windows?" And we're like, "Yeah, yes we are." And they're like, "Oh, that's cool." 2 hours later, that person happened to be one of the core contributors of the Google Cartographer, and they had ported Cartographer in about 2 hours. So, or hour and a half, 2 hours. And they came in and said, "Look, we have Cartographer working on Windows." So that was pretty exciting. When I did a blog post, and this was kind of funny. ROSCon 2018 was actually in Spain. So when we launched ROS on Windows at ROSCon 2018, as the world turned, and people were waking up and looking at the Microsoft blog, it was like a whisper down the lane of what had been launched that night. And as they translated people's stories to different languages and then translated back to English, it was really kind of wild to watch the story change as it went around the world and came back to Spain. At one point, they were saying that Microsoft was building robotics operating systems and, throwing out Windows. It was all sorts of really fun stuff, but we had to go correct all of that. Is there some reason Android Things isn't going forward on the Pi? I don't know anything about Android Things, so sorry about that. Okay, so let's talk about ROS on Windows itself. ROS core, we mentioned that the core of ROS is the thing that does pub sub and messaging and debug tooling and storing messages for later playback and simulation, right? So that's the core itself. But the reality is ROS community is gigantic. Tens of thousands of ROS nodes that are public and many more that are even private. So Microsoft just couldn't start from A and go to Z and port everything. We would be there for 5 or 6 years doing that at the level. So what we decided to do was take and cut through mobility and manipulation. So we said, let's just light up some core scenarios for mobile platforms and manipulation. And then we'll grow the ecosystem based on customer feedback. Our hope here was that there would be common ROS nodes and common dependencies between them. And it turned out to be pretty true. Enabling a ROS node on Windows is getting easier the more we support. Okay, let's see. Okay, so let's talk a little bit about ROS 2. I'm very bullish on ROS 2. Like I said, it's the Arduino that's going to catalyze that maker moment for robotics. We are on the ROS 2 Technical Steering Committee. One of my reports, Sean Yen, is the committee chair. He's also on the Dev Tooling Group. And what else are we on? I think just the Dev Tooling Group. We've enabled ROS 1 and ROS 2 coexistence on Windows. The way that works is you have separate environments that share dependencies. We're working on documentation and videos, developer tooling, first-party ROS nodes. Like I mentioned, the manipulation pipeline and navigation pipeline we're also contributing to. And we're doing enterprise-grade containerized deployments. And eventually we'll offer enterprise support. We'll talk about that for ROS 1 at the end of the deck. So here are some of the ROS nodes that we do have. If you're familiar with the Azure or the Microsoft Kinect, there are 3 versions of it. There's the Gen 1 that was associated with the Xbox 360, fairly ubiquitous in robotics. It's really cool. In fact, there's such an aftermarket for it that it's sometimes hard to find. The Kinect Gen 2 works a little bit differently than the Gen 1. A little harder to consume on something like a Raspberry Pi. When we shut that down, we got a lot of feedback going, hold on a second, what did you do? That they spun up a team to work on the next generation Kinect that we call the Kinect DK. It has a 4K color camera plus the depth sensor is out of the next generation HoloLens. That depth sensor actually has 2 different fields of view. And it works as a time of flight camera. So there's a strobe, and it measures how the delta between the strobe of light going out and how long it takes to come back. So that's actually kind of cool. It does have a wide field of view with a lot of pixels, tons and tons of pixels. The reason for that is that they want, with the HoloLens, they can actually do digit or finger detection for manipulating holograms. And it works really well for robotics platforms. It also has a machine learning node built under the covers to do body tracking. And this works in 3 dimensions, which is really neat because you can actually do things like find the shoulder of somebody and then figure out where their arm is. Where a lot of body tracking is actually in 2 dimensions. You kind of see this instead of this. So, and then we had a community member enable body tracking in the ROS node, which publishes the joint as a tracking object in 3 dimensions. How much does it cost? It is $3.99 and is available in the US, Germany, China. I think they just launched it in Japan and working on Canada. But because it has a laser, it does require a lot of certifications in various jurisdictions. So that's why it's not necessarily worldwide yet. Now, the Kinect DK works on Linux and Windows. It does require a bit of a powerful computer. So this one won't work on a Raspberry Pi. The body tracker does require a NVIDIA GPU. It actually is built using CUDA. So it does need an NVIDIA GPU and a fairly powerful system. So just an FYI on that. Okay, so we talked a little bit about machine learning. Microsoft invests heavily in the Onnx runtime. Now, Onnx is a standard machine learning model that encapsulates various stages of machine learning so that you can take input from cameras or sound files or time series data. You can create these with tons of different frameworks using things like MathWorks or Azure Custom Vision Service. And hold on a second, I have a snoring dog. Sorry about that. So you can take this Onnx model, which is just a file, and you can put it on different systems. Some have support. The file is supported on things like TensorFlow and Windows Machine Learning. Let's see. So that is the Onnx runtime ROS node. Our ROS node currently supports just Windows at the moment, but as we port it to ROS 2, we're also going to enable the Onnx runtime, which allows it to work on multiple platforms. Any questions on that one? Okay. We also support the Azure IoT Hub ROS node. Now, you may not be familiar with the IoT Hub, but it's a solution from Microsoft that provides cloud connectivity for IoT devices. Each device in the environment has an identity, and it can subscribe to what's called a digital twin. It's a representation of the IoT device in the cloud that cloud services can operate on, even if there's no live connection to the IoT device. So in this case, we treat a robot as an IoT device. One thing that you can do is subscribe to ROS messages from your cloud services. You can use that to do machine learning or time series insights on that data, which can ultimately call functions in Azure or call to your cloud services, which generates data through the IoT Hub that can run back on the robot. So why would you want to do something like this? Well, if you want to remote monitor your robot, for example, you want to make sure that the battery is always charged or the battery capacity isn't falling below certain levels. You can actually subscribe to battery data and use a time series insight to monitor the fluctuations of the battery to see if, well, maybe the capacity is declining and we need to dispatch a ticket to have somebody go change that battery. This is more for the industrial side, but it can be used for things like remote monitoring of home robots. So if this is something you want to play with, it does work pretty well. Let's see. Now, I think this one is one of the things that I'm really proud of is the Visual Studio Code ROS extension. This actually started as an open source project by somebody in Australia who handed it off to us and said, "Hey, this, I started this, but would you, take it over?" So we took it and added a lot of features to it, and it is hugely popular in the ROS community. If you're not familiar with Visual Studio Code, it is a lightweight version, or it's not even a version, it's a lightweight debugger editor solution for building all sorts of applications. Runs on Linux and Windows, and one of the things I love about it is the extension ecosystem. So with the ROS node for Visual Studio Code, it supports ROS 1 and ROS 2. You can debug ROS compositions, and you can also do things like edit your the robot descriptor. Now, I mentioned the robot descriptor called the URDF, or Uniform Robot Definition File, gives an orientation to sensors and actuation so that you know how data, or how the sensor data is applied to the system. So for example, LiDAR that's spinning around, the LiDAR has its own origin, but how does that relate to the wheels of the robot, and how do you transform that? That's all through this URDF file. It's also used in simulation. So if you can do things like specify where the center of gravity of your robot is. So if it tilts too far, the simulator will actually tip it over. So that's pretty fun. And you can download this through the Visual Studio Extension Store. Just look for ROS. Just make sure you don't install the deprecated one, because they can conflict. So we're going to figure out how to do that, how to make that not as conflicty. Conflicty is a technical term. Yeah, we have been contributing to the ROS 2 working group's GitHub action. So when you check in code to GitHub, it can kick off a build and generate packages that can be installed on Windows or Linux. We've also added what we call continuous simulation. So not only can you run tests and package on GitHub or Azure, you can spin off a simulation. So as part of your engineering processes, you can run tests in real environments, well, simulated environments, and get the data back as a pass-fail to check-ins, or to continue to ensure that your robot stays at high quality. And one of the reasons we did this was not just because it's the right thing to do, but it also helps to bootstrap the ecosystem and keep the ecosystem in lockstep between Linux and Windows. Let's see. No more questions. Oh, is there scrolling? Oh, there is a bunch of questions. It doesn't auto scroll. So I'm going to stop there. Let's see, and answer a bunch of questions. Do you have a beta testing working group for the Azure DK ROS? We do everything through the GitHub account, or the GitHub issues, and we do monitor the ROS ROS Answers, which is the forum for ROS. We don't have a formalized working group. Pretty much I'm the only person who works on it. Let's see. Does Onnx work with TinyML? I actually don't know if TinyML has an Onnx runtime. It might be the Onnx runtime uses TinyML internally. So the question about cloud to ground. I mentioned that our team is Edge Robotics, which means that we're focusing on the robot side, not necessarily the cloud side, because the latency to the cloud is just something that's always going to be there, no matter how fast we make the connections. You know, a common refrain is 5G is going to solve all of our latency problems, and machine learning is going to give us, I think they called it negative latency, because we can predict the future. It's not going to happen. The latency of the cloud is just too great. That said, the cloud does really great things up front. DevOps, orchestration of multiple workloads, back-end data streams, back-end training, tons of great things that happen in the cloud. But the robot needs to be able to operate autonomously, independently, and safely, and any disruption can cause problems. My son who's playing video games upstairs always will say, "Dad, the internet's lagging." Well, when the internet lags and somebody dies in a game, oh well, you respawn. If the internet lags for a robot, it can damage infrastructure, product, or people. And then we don't want that to happen. How do I get access to aka.ms? So it's actually aka.ms/ROS. Okay, I think I answered all the questions there. Okay, so enterprise grade support. One thing we've heard loud and clear is ROS is great, but what happens when I take a dependency on it in my factory or in my warehouse and something goes wrong? Well, Microsoft is offering enterprise grade support for ROS on Windows so that you can take advantage of Windows in your environment, and we will support ROS and specifically ROS nodes on. So this is tied to the enterprise support contracts with Windows IoT. Okay, so at that, I was going to go into some related activities. So we have a number of partner companies that you might be interested in. ClearPath Robotics is one of our premier ROS support ROS partners. They produce a number of commercial and industrial grade robots that have been deployed in mines and wind farms and solar farms and regular farms. ABB supports ROS on Windows. So if you have one of their cool ones is this 2-armed robot called the Yumi that supports ROS on Windows. Highwind produces is one of the largest manufacturers of robots in Taiwan. Of course, we're a member of the ROS Industrial Consortium, who is looking to take ROS into industry. Robotics produces the Turtlebot, and the Turtlebot works great on Windows and works with our cloud services. And we have a bunch more in the pipeline. So what are some coming soon things? So I mentioned earlier about supporting ROS 2, but we're also enabling a couple of new ROS nodes, including our language understanding service, which is how you can talk to a robot and get inferencing from the cloud. So this is one of those cloud technologies that when you say something, you get we inference the data in the cloud, figure out what you're trying to say, and then convert that into a language the robot can understand. So for example, move forward 5 feet or move forward 2 meters, the language understanding service will actually turn that into a move command and a length command that has been neutralized, that's pretty cool. Wi-Fi 6 indoor geolocation. Well, this is a neat technology in next generation Wi-Fi, which turns your Wi-Fi deployment into an indoor GPS solution. So we're producing some stuff for that. Our Media Foundation ROS node, which is our camera stack, is currently available, although we haven't it's soft launched at the moment. It also has its own vision skills, which uses machine learning in Windows to do inferencing on the data that comes from the camera stream. And one of the reasons why we did this separately is that the speed of Media Foundation over the traditional tech is significantly higher. So not only is the overhead less, but the CPU utilization and the data is significantly less. So using the native media mode will reduce CPU usage and bus usage. So did I hear a nope? Okay. And then finally, we're working on GPS RTK and GPS muxing. The indoor location and outdoor location are 2 different GPS solutions that don't necessarily work together. So we can mux them and choose the most accurate based on the data that's been published. So that'll be coming soon. We're also currently working on the Mixed Reality Toolkit ROS module. So if you're not familiar with the Mixed Reality Toolkit, it is a programming model for working on AR and VR. It has a lot of really cool controls that work in VR, so buttons and lists and console type solutions for building VR applications or augmented reality applications. It's really designed for the HoloLens. It works great for the HoloLens. We're working with the ROS2.net team to bring ROS2.net up to the point where you can use ROS2 and the HoloLens together. Basically subscribing to sensor data, pinning holographic space and robot space together so that you can transform sensor data through the robot to the HoloLens back into the user's display. You'll actually be able to see sensors from the robot perspective. We're really excited about this one. We're also working with the Siemens ROS Sharp solution for ROS1. So you can connect to a ROS1 robot or a ROS2 robot from the toolkit. And it is exposed as a set of tools that you can use to build your own holographic applications. So this isn't really a product as much as a set of development tools for you to build your own solutions. Okay, I'm still at the end of the message list. Okay, so this is kind of what it looks like right now. Widgets for ROS. So right now what you're seeing here is one of the visualizations for LiDAR, and that object in the center eventually will have the URDF, the actual robot model, projected in space. If you happen to be in VR, you get the robot model. If you're in AR, you actually just see the robot, and then you see the LiDAR data as it hits real things. So that's pretty excited about this one. Now, we have some other partner teams that you might be aware of. AirSim is one of our partners who are building a simulation environment for drones. Turns out drones are flying robots. And it has a ROS connector. So it does photorealistic simulation. It's designed as a plugin to Unreal so that you can build your own environments and use your own solutions. It's optimized for closed body simulation, so a drone or a car or maybe a mobile robot. It's not really designed for manipulators or open kinematic solutions like a robot arm. Bonsai is a cloud-based reinforcement learning framework. Reinforcement learning is a subgenre of machine learning that basically tries out a bunch of different solutions and converges to the best one. It has a domain-specific language that allows you to create a reward function as you try different solutions and converge to different behaviors. So, for example, the canonical example is a balancing robot where you actually want to balance a pole. So how do you move the carriage so that the pole balances on the carriage? So that's one of the canonical examples. But it turns out that testing the balance of a pole and moving it is essentially a robot. This one is more for the industrial and commercial side. So Connected Field Service is a solution from our Dynamics team that allows you to dispatch tasks, tickets, support solutions to people. And it works with IoT Hub, so the robot can generate events that the Connected Field Service responds to and says, oh, this robot is stuck. Let me go create a ticket to have somebody go unstick the robot or go replace a battery or go replace a wheel or something like that. And I mentioned our mixed reality toolkit. We are also in cahoots with our mixed reality team. There's a mixed reality robotics research team in Zurich that we interact with quite a bit. And of course, we're working on a FarmBeats solution so that we can use robots to generate data for our farming, our farm solutions. So this is another team they may interact with. Anyway, that was my presentation. I wanted to thank you very much for inviting me. I will stick around for questions afterward. If you want to check out ROS on Windows, I posted into the chat window our landing page It's a skill. It takes time to get used to, and there are a lot of nodes out there that are in different states of living, so sometimes it can be hard to find solutions. We are monitoring answers.ros.org, especially if you tag Windows, if you're using Windows, or if you hit something specific, just go ahead and post an issue on our GitHub. Now, I also am giving you our email address. This goes to our feature team. So, if you hit something real, you're struggling with it, feel free to email here. We may drop that alias in responses, but feel free to reach out to us. And if you have an account manager, like if you work at a company that wants to onboard robotics and you're working with someone at Microsoft, have them reach out to us as well. Anyway, thank you very much. I will stick around for questions.
Thank you, Lou. Pretty cool presentation. I think we're all just blown away, probably. And we have a probably pretty wide range of backgrounds and experience on the call, I would say. So I wanted to ask. There's a couple of questions here, and I was one of the people to ask it. And so, if we were just getting started, would we get started with ROS 1 or ROS 2? And what would be simple ways to get started if we really wanted to get in and kind of minimize that learning curve?
That's actually a fantastic question. The first thing I would say is, what do you want to do with it? If it's mobile robots or manipulators, you probably ROS 1 is going to be get you to where you want to go faster, because I mentioned the subsystems are missing in ROS 2 or still in bring up in ROS 2. If you really want to just understand ROS itself and use it and do your own bring up, ROS 2 actually might be a good place to start. It's a lot easier to use, much more modern, much more simpler to get up and running. I'll post a couple of links in here to some kind of getting started guides. The typical, I guess, the Raspberry Pi of ROS is the Turtlebot 3, a burger, which is a small robot. And I'll post the link to that one.
Because I know, at least from the DPRG side of things, we tend to have a lot of heavily embedded kinds of designs, not so much those which are cloud connected, but literally C and Python kinds of things, all self-contained. So it's interesting to start to think about pub subsystems, and if we were to kind of learn, for example, would we have to go all the way to a Turtlebot, or could you even start small, or can you get like an instance of ROS on a Mega or a couple Pi 3s and then have them interact with each other, for example?
Yeah, so if you're interested in using multiple Pi 3s talking to each other, I really love DDS, which is the underlying pub sub for ROS 2, and ROS 2 is up and coming. So I post actually. So this is a nav2, a really simple way to get started with nav2 in simulation.
Cool.
So this one, it does work on Windows today, but once you kind of understand how to use it, then translating it to Linux would be just fine, and then you can get started there. I think that ROS is really more up the stack than on the embedded side. So if you're working with just microcontrollers and kind of low-end systems, ROS is really about that next level. It's not real time, or let me rephrase that. ROS 1 is not real time. ROS 2 is kind of soft real time. It doesn't do, like, you want to run your PID controls on the microcontroller and then just expose an interface up to ROS so that you can do more advanced things. So, navigating your house, for example, is really where ROS is where you would transition from low-level robotics to your higher-level robotics. And then,
So from our kinds of projects, then, if we would have our traditional kinds of robots handle, like if they're mobile robots, navigating around, recognizing objects, grabbing objects, if they wanted to use higher level functions, then we could keep the PID loops and things contained locally. But it sounds like then we could ship the vision and such off to a laptop and have ROS doing the more complex higher level things.
yep. Or Raspberry Pi 4. Pi 4 is surprisingly good for some of your for small scale robotics. I'm really bullish on the Jetson Nano, which has the machine learning and hardware inferencing. So that's actually a pretty cool board. Somebody asked about simulators. ROS Open Robotics has developed the Gazebo simulator, which is fairly ubiquitous in the ROS community. Microsoft has built the AirSim product, or AirSim research platform, which has a ROS connector to it as well. So if you're building flying robots or maybe outdoor robots, AirSim is pretty cool. Gazebo is more supported in the ROS community. Yeah, Ponder some more, I think nailed it here. ROS is a way of composing lower level behaviors and sensing. So it's really about, like, once you actually have your robot moving, how do you actually give it some advanced behaviors? And it's composable, which is what I really like, is because you can take vision systems from here and nav stacks from here and sensing from here, and then you compose them for your robot and build the behaviors on top of it. So, like, for example, Amazon has a RoboMaker product where you can dispatch from Alexa to through their ROS nodes. So and we will be building the Lewis node, where you can talk directly to the robot and have it generate behavior. So those are some cool things that are built because ROS is the common language that you can take pieces from different companies and build them into your solution. We have a good relationship with the Ubuntu robotics community, or robotics team, and we're talking about hybrid deployments where you can use Windows for your host and use some ROS nodes inside of the Windows subsystem for Linux, or use the Windows subsystem for Linux to target a Linux-based robot. So these are the things that you can enable because you've bought into ROS. The other thing it does enable, or ROS enables, is having some things work on Windows and some things work on Linux. So if you want to use your visualizer on Windows, but connected to a remote Linux robot, you can do that. You can drive around from using an Xbox controller on your laptop and have it communicate with a robot remotely. So like I mentioned, I am bullish about ROS 2. It's just right now it's a little bit more, it needs some work before it will become more usable. I mean, it's usable now. It's just, it's not as robust as ROS 1. Is Microsoft working with the farming and cattle industry via Dynamics and ROS? So Microsoft as a whole is. We have a team called FarmBeats, which is an agricultural platform. We have a lot of IoT, or Internet of Things, is actually about commercial and industrial solutions. Not so much your light bulbs and thermostats, but more about how do I track cattle production, or how do I track nutrition? How do I track the comings and goings of different farm animals, or how much yield is in the field? So that's actually something that Microsoft as a whole is working on. Those teams traditionally have looked to drones to help gather some data for agriculture, but as I mentioned, drones are really just flying robots, and a lot of drone flyers are looking to ROS and saying, hey, can I want to make my drones smart. What can I do with this ROS community? And they're starting to overlap and connect to each other. So that's what one of the things we're doing with the farming, or what we call a solution accelerator, is to show how you can take an outdoor robot and use it to generate data for this farming solution. We're going to have 10 billion people on the planet here soon, and we can't feed them all today. We got to do something.
Hey, Lou, this is Harold. I want to thank you personally for volunteering to do all this kind of thing and answering my email and all that kind of stuff. I know it seems to a lot of people that, oh, those people are up there in Redmond or in the mothership and you can't get a hold of them, which is absolutely untrue. And you're a fine example of that, by the way. Also, as far as contributing to things, and taking a bit to get into all this stuff, I jumped in the deep end in ROS 2. I'm still trying to get things going and doing, and I'm struggling a bit, but that's okay. I'm learning stuff as I go because it's not my day job, and so it takes a little bit longer, you know, for doing things. And I will tell you though, as far as contributing and things to it, I am a contributor on the ROS GitHub thing. I had a PR accepted. It was a total of 1 character on a setup document and equal to a space, but I'm a contributor. So, and I'm happy to help, and I'm looking to contribute more. But I also want to shout out to folks that I'm trying to work through this myself and figure it out. And for the local club members, the local people, I'm more than willing to, I don't know very much, but I'm more than willing to share everything that I have and help anybody that wants to try any of this stuff go forward. And I am firmly into ROS 2, and almost everything on the web out there that you see is going to be how to do this under ROS Core, which is ROS 1 stuff, and which is a little bit frustrating for me, but I figure if I keep playing at this, there'll be more ROS 2 stuff out there. And I'm just trying to help. And that's what it comes down to.
Well, I appreciate that. You know, ROS is my day job, and ROS 2 is, I struggle with ROS 2 as well. So, you know, it is, you know, I spent, I'll give you an example. I was recently working on a action client, which is how you command and control a robot to say, go to a specific point. And, you know, the action client subsystem of ROS 2 sometimes just says, no, I don't have anybody serving action, sorry. And it's like,
So I go
why?
home. Yeah.
You know, I have no idea why. So was it a Windows bug? No, it turns out it repros on Linux as well. So, you know, we're trying to root cause why action server doesn't work, so that we can help make ROS 2 more robust. I'm going to post a link to our YouTube channel. We're in the process of actually resurrecting this. As I used to be on the Microsoft Maker team, I was one of the architects, and we used to publish videos at least monthly, sometimes every other week. And then as we shifted towards industrial solutions, we kind of let this kind of die, but we're trying to bring it back. So I'm going to be posting some getting started videos for ROS 1 and ROS 2, as well as how to use each of the different subsystems, how to use Visual Studio Code and things like that. So I think many of us would like to have a robot self-contained, running on a higher end video board, whether you can add, well, it gets quirky due to latency. Yeah, so Edge really is about the things that happen on the robot or in your household. So not necessarily the things that happen in the cloud, although we do, you know, we do work in the cloud when it's appropriate. A lot of our focus is the on-robot solution, because yeah, a robot's got to do what a robot's got to do, whether or not it has connectivity. And that's really where our focus has been. I have not really found ROS courses on Udemy or what was another one? But the Construct on YouTube is a really good channel. I think they post at least weekly, and maybe even in a couple of days. And they're really great they've got courses and they do online stuff. Like if you want to learn ROS, the construct is the way to do it. They do have free videos, but they also have paid solutions, and it's worth. I think it's worth it. It's good stuff.
I was going to comment, if you do have the publish that, it'll be good, because about 5 years back, I had one of those ROS vacuum cleaner thing, and so I did look into the ROS then, but it's been a while since then. So, and then you were saying that on the other, robot machines, which ones are good? You said it's Dribble?
You chopped up quite a bit. I'll answer the question I think you asked, and you can let me know if I didn't answer it. So you had asked about what robots were good to get started. Was that what you had asked?
Basically, yes. In other words, I had as I said, the Rumba vacuum cleaner thing where you could interface it to it. And then there's one other one, Scribble, I think it could be, but that's a couple of years back. So I don't know what the current clumps are. So
the most supported platform for getting started is the Turtlebot 3. Did I post that link? No, I opened it up. It's the Turtlebot 3. There we go. So the Turtlebot 3 is a product by Robotics. They are mostly known for their servos. So they use 2 servos on the wheels. Plus they have a controller board that's actually a pretty good Arduino compatible controller board. And it comes with Raspberry Pi. So and a LiDAR. So LiDARs I like LiDARs. But they just shoot lasers out to figure out the distance relative to their environment. What a navigation solution will do is take those points in space and keep track of them over time so that the robot gets memory of where it's been. Once it has a memory of where it's been, you can tell it to go back there. And you can do things like, this is the kitchen or this is the living room, to give it an idea of where things are, and then it can go back there, which is kind of cool. LiDAR is really great for. It's great when it is great, but it's terrible when it's not great, which is a weird way of saying, because it's shooting a laser in a plane. If you have a lot of spindly things like fences or chairs or tables, then the robot won't be able to see those. So you really do need to fuse it with other data, and that's where depth sensing tech comes in. The RealSense is one of is a really great depth sensor because it is compact, low power, and it doesn't actually require a lot of processing to get depth out of it. Whereas something like the Azure Kinect is really great because you get so much data out of it, but it does require a bigger processor in order to get the information out of it. So if you have the processing, then the Azure Kinect is great. If you don't have the processing, the RealSense is great. But it really doesn't matter if you write your code to use the point cloud that comes from a depth stream. You just swap in a different hardware as you need to. So that's one of the things I really like about ROS. I did mention that I am working on a Hero 1, which was released in the early 80s. I found one on eBay, but it's got a robot arm and wheels, and it's got some sensors on it. The sonar is like this big. For an equivalent modern sonar is like this big, but it's really neat to see how far we've come over my lifetime. So, what happened to the DPRG Turtlebot?
Okay. Yeah, so we have in the club in Dallas here in storage, I thought somewhere we still have one of the original Turtlebot 1s. And I guess the question is, since we are a club and it is a Turtlebot, could it make sense that we maybe upgrade it somehow so that it could be a platform for us to play with ROS in the club?
Absolutely. I think the biggest problem you're going to have with the Turtlebot 1 is finding a battery for it. But you could probably construct one. I think it was just nickel metal hydride. Yeah, so Turtlebot 1 has and Turtlebot 2 have a well-defined USB interface. So once you have the ROS node for the Turtlebot 1, just talks serial. So you plug it into a Raspberry Pi, and suddenly you've got a new robot. So that's one of the things. We have had ROS running on robots from the 80s, from the 90s. We've old robot arms that are made intelligent because you build the connector for it, and then it takes advantage of everything upstream from ROS. We've seen ROS in factories, running whole subsystems of a factory line, and we've actually worked with automotive manufacturers on mobile platforms that just use ROS. In fact, one of my favorite stories is we had a demo of the Turtlebot 3 turning to find a person. And we went to I can't say which automotive company, but we went to an automotive company who had a ROS-based robot. And within minutes, we had that robot talking to our subsystem that pointed the robot at a person. It was weird seeing this gigantic robot turning towards a person, but that was the, hey, can this work? And it was literally minutes.
So we can blame that overlords take over and those sorts of things, right? At least I'm going to claim at least partial credit because I'm trying to help them, be smarter myself. But I just.
You should, Harold. You've earned it.
Yeah, I'm not too worried about the robot overlords taking over. Honestly, they're not exactly the most smart devices right now.
No, not at all.
Yeah, it's funny because I'll have conversations where it's like, oh, machine learning is going to solve that, and it's like, well, okay, maybe someday, but I think the singularity will happen first.
Probably needs to.
Yeah, I was just looking, and I've looked at before the Turtlebot 3. I do believe if we would like to try to build some of those, I know we got a lot of parts laying around. Like, I'm sure that Carl has a few LiDAR things laying around somewhere, and there's somebody's got some STLs for all those plates. I bet we could print a bunch of these stuff up, bunch of these together, and we could put them together, and get a little hardware actually. If to print some things, and then we all have stepper motors laying around. I got a feeling we got a plethora of them.
We amongst us, we do have several garages full of parts, don't we?
Let's once you actually start publishing, so a little bit deeper into it, there is a project called ROS Serial that allows you to run a portion of ROS on an Arduino.
All right.
Okay. And what you can do with that is accept command velocities and turn that into wheel motion. Okay, so it basically, you subscribe to a topic called /cmd_vel, and it gives you an angular rotation and a forward velocity. And you turn that into your differential drive or your Mecanum drive or whatever drive system you want. There's also Ackerman steering, so if you want to do like an RC car. So once you're communicating with the ROS ecosystem, you can start getting those commands. You can also publish some things off of your Arduino. So for example, how far the wheels have moved. So if you can collect information about how far you've moved, you can publish what's called odometry. And that's basically, you're told how fast how fast you should move, and then you report up, this is how far I think I've moved. Mm-hmm. The projects up above you that do things like localization we'll be able to say, okay, well, if the motors have moved this far and the LiDAR has said this is what it looks like, then this is where I think this LiDAR is now. So now I can send different commands to the base. Okay, and that actually gives you that where you're building just these little tiny adapters to take advantage of a big ecosystem.
So I'd hope that was the case, that there were some very small Arduino type things that could react to commands and emit data that would live on the Arduino, and I just need to go find them now, I suppose. So, you know, we attach that to the motor controller to tell the motor controller to do whatever, and then have that Arduino thing interpreting and relaying data back up. Cool.
Yep. Let's see. There was a couple others in here. I noticed that the talk didn't actually include any, robots. Can you show us a video of a robot doing amazing things to justify all the complexity? Oh, that would be a great idea. So I actually did have some videos, but they don't stream well. On our YouTube channel, we have a couple of videos. So here's a video of using Azure Speech Services with a robot being driven from the controller. We also did announce with ClearPath Robotics.
I've seen a few videos up there where it's got like a 2-armed robot doing some things in a multiple degrees of freedom things. I'll see if I can't look it up and post it up to the club, because I've seen a few of those things that were really, really neat.
Yeah, so let's see if I have one from one of our customer videos. So I posted a couple videos. ClearPath, I love ClearPath robots. They're awesome. They're kind of on the expensive side. How much time do you think it will take for you to write HAL for your hero? So let's see this. I'm actually more worried about the hardware right now than the software for the Hero one, because the serial drive, there is a community member who's built a serial or USB serial interface for the Hero, and I like to use either the Jetson Nano or the Latte Panda. So if you like Windows, the DF Robots Latte Panda Alpha is really awesome. But the board, about the power of a modern laptop, is about this big. I can stick it in some of the void spaces in the Hero 1 and start driving it around. So I don't think it'll actually take that long. I think most of it's going to be like, well, how do I do voice commands? How do I do gestures? How do I mount the Kinect without destroying the robot? So those are more of the questions I think I'll have. Building a ROS node that takes command velocities and outputs odometry. I've done it a couple of times. It's not. I mean, it just takes coding to build the adapter. I have I'll do a video on it, but I have a Power Wheels racer from a toddler that we turned into a race car. And it's got a Arduino Mega for the controller, or for the drive control, and then a Latte Panda as the controlling system. And we can we can race them. And the code for the Arduino probably took me about 2 good days to make work. And that includes driving a external motor controller, getting sensor data off the platform, doing IMU, so that instead of using an IMU as opposed to a quadrature encoder for speed, because IMU in this case, if the wheels slip, you don't necessarily have an accurate estimation of position. So we're using IMU instead. And I'll post. Actually, I may have that up already. Is there any other questions? I think ROS is worth learning, and there's opportunities on Linux and Windows, which is really what I wanted to convey here.
You made a pretty good pitch for it, Lou. It's it'll be interesting now to start digging into some of these videos and such, and see where we take it.
Awesome.
All right. Well, if there's no more questions, one more question for you, Lou, just on the chat.
Yep. So ROS 1, they do yearly releases of ROS, and in those yearly releases, they call every other one a long-term support. So the currently supported long-term of ROS 1 is called Melodic, and that will be end of life, no more support 2023. So that's both Microsoft and Open Robotics are saying no more ROS 1 after 2023. There is a next generation one called Noetic, but that one's not technically a long-term support platform. And they are doing work to transition it to Python 3 because you can't even install Python 2 stuff anymore. Like it's that kind of, Python is more end of life than ROS is. So, when you install ROS on Windows, we actually have to lock Python to a very specific version that we know works, because if you update it at all, everything falls down because Python 2.7 is just not supported anymore. So 2023 is when the current generation of ROS 1 is no longer supported. ROS 2, they just released the Foxy release of ROS 2. So that will be supported until 2023 as well. And then what they're calling GTurtle is the next generation one.
And then I think David did a question about, are you double integrating velocities from an IMU to get odometry?
I would say fusing is a better term. So the fusing, each sensor that you have has different capabilities on interfacing with the environment. So an IMU is really great in short bursts, but over time can drift. A camera is really great because it can see the environment, but it only happens once every 30 times a second. So there's a lot that can happen in 33 milliseconds. So IMU gives you that short burst between pictures, between frames, to say, okay, well, this was the motion, and this is why you see something totally different, because you move fast in between those two frames. So you really are about interpolating those and fusing the sensor data. Unless I misunderstood your question, double integrating the velocities from IMU to get telemetry. Oh, you mean double integral?
Yeah. So I think if this is the same David, yep. David does remarkable things with, I think he calls it spinal level logic. So Lou, you're coming at this from very cerebral, esoteric level logic, and David does robots that are really quite capable, but they using things like subsumption architectures, they exhibit relatively complex behaviors with relatively simple logic, without all these fancy, dinner cooking GPUs and things.
Dinner cooking GPUs,
right?
For the Ackerman Drive robot, no, we're not doing anything terribly advanced with it. The odometry really is about short burst. How far did I move? In order to inform the localization system where that new data from the LiDAR and camera sensors should be localized against. Because, so no, we're not actually doing anything terribly advanced with the IMU. It's really just an alternative to the encoder, because we know that the wheels are highly likely to slip in a race. In fact, when you drift around a corner, they're just going to slip. So odometry doesn't really make sense. IMU over short periods work really well to say, look, I think I moved this far, so interpret this data from this perspective, and the localization tool or the localization subsystem will try and match up the point cloud so that it goes, this is kind of how I think they work together. Okay, so if you take discrete frames of image data and try and stitch them over time, they'll kind of match up. And what you're trying to do is give the system some extra information about how those point clouds match up. So
it
no,
sounds
not
like
very. Go ahead.
if I understand what you're saying, then when you're talking about fusing it, it sounds like these higher level ROS systems can fuse multiple different sensors and types. And I think you mentioned IMU, LiDAR, encoders, and cameras. So when you're talking about these localization systems and understanding where the robot is in a kind of a general space, are you talking about those higher level ROS systems as being able to fuse all of those different sensor data together to give an estimate of position in space?
Yes. So that's so someone asked what IMU I'm using. I'm actually just using an Adafruit 9DUF IMU that I'm reading from the Arduino. So servicing the encoder and then batching up 5 or 6 samples that we send up through through ROS. And for the localization, localization and mapping are kind of two different things. I'll look it up afterwards. But with localization, what you're trying to do is saying, my sensor data is coming in at a certain rate, but how do I interpret that over time? I can try and do it algorithmically by matching up the point clouds and say, look, this is, if you're going down a hall, they kind of, all of your point samples look the same, right? So it might not look like you're moving at all. So what odometry does is it gives you some extra information to say, look, I think I've moved, a meter over this time frame. So as you're getting the samples, it's just kind of stitching them together. And then there's different phases of localization where it tries to resolve things like loops. So like if you drive around your house, you might end up with, because of errors in your sensor data and odometry, you might end up with 2 things that don't match up. So then the system goes through a resolution to say, okay, I think these are the same points, but they don't match up. So let me try and change everything to stick them back together. But that's really, that in the simple case, if you're driving down a hallway, your sensors might not give you enough information to say that you're moving. So you need something else as an input to say, hey, you are moving, so interpret this data as if you are moving. But those are things that are happen up in your navigation stack, and there's a lot of research going on from universities all over the world who are publishing different types of localization and mapping solutions. I mentioned the Google Cartographer, but there's ETH Slam and Orb Slam and what else? G mapping is a popular one. OpenCarto, dozens. There's proprietary solutions as well. The reason that there are so many is that they work on different principles, and they're optimized for different environments, or different sensors. Some work really great with LiDAR. Some work great with cameras. Some work great with depth sensors. Some work great indoors, some work great outdoors. So you kind of have to figure out which solution works for your scenario. But from your perspective, when you're just if you're building a robot, welding together the frame and putting sensors on it, you don't have to worry about the PhD level computations that need to happen in order to localize your robot, because man, I just want to build a robot. I don't really care about how it finds itself around space, or let other people handle that. And that interface, because you buy into the ecosystem will take care of you. So let's see, the Adafruit 9DOF
Yeah, we've got several of us talking about the BNO 55. We have a couple of club members talking about optical flow sensors, so there's interesting discussion on that right now and various alternatives for those even.
Ooh, this is new. I like this one. No, the one I'm using is not even produced anymore by Adafruit, so and it works fine. You know, the more accurate, the better. The more that you can fuse inside of the sensor, the less processing you need to do up above. And I really love the quick interface.
The Spark Fun.
Oh yeah, and even Adafruit is buying into it as well. It really works well. One thing I think I found there is somebody producing an interface for the Jetson so that you can snap it onto the Jetson and get quick there too. It would be actually kind of interesting. I think there's motor controllers as well for quick. So being able to snap on a motor controller and just have a differential drive robot, that would be super cool.
Okay, well, we've taken a fair. Oh, go ahead. Go ahead, Lou. You had something.
Oh, somebody posted, "Can you just adopt us?" Well, I am one of you. Hi, Mary.
Well,
yeah, working at Microsoft is we get a large intersection of companies and people that have all sorts of different backgrounds, and it's really cool. I really do enjoy Microsoft, and they take care of the community and employees, and we get to do really interesting things. Robotics, as old as robotics has been, the future of robotics is really bright, and I think that when COVID has been one of the things where people are starting to go, well, can we automate this? Like, we need social separation. We need to sterilize environments. We need to deliver to people who, where you don't want to physically interact, you can't physically interact. So we're seeing a lot more interest in the retail and commercial robotics side, and I think that ROS is going to play a huge role in that. So. And I also mentioned, 10 billion people on the planet. We've got to feed them. We've got 1 billion people go to bed hungry every day today. How do we feed those, and how do we feed the growing population? We need automation in the farming. We need intelligent automation. We need to be smarter about how we produce food and get food to where it needs to go before it rots in the fields. So, personal passion of mine. Another personal passion is what I call human inclusive robotics. Robots can't replace people. Like, they need to augment us. They're not about changing out replacing us in the environment. So our work with the Language Understanding Service and the Mixed Reality Toolkit are really about scaling people and keeping people in the loop. So anyway, that was my passion pitch.
That's cool.
And the interesting thing is, like, if you buy into the ROS ecosystem, then the stuff we do in HoloLens or whatever mixed reality or augmented reality headset comes out next, it just works with your robot, which is kind of cool too.
Lou, I think if you look closely on your attendee list for Ron Dagdag, and if he moves his head around, you'll see someone who's already augmenting himself with mixed reality.
Yeah,
Ron lives in mixed reality.
Resistance is futile.
That's how you augment.
Ron's reality is mixed reality. That's what I think.
Well, I'm amazed. That thing is locked on tight.
It is.
And there's no lag on turning your head. That's really awesome.
You should see when he puts himself in the jungle with his little explorer hat. It's pretty cool.
So I gotta ask: is that a purchase product or something you built?
It's Snap Camera. Snapchat, right? But they have a way you can install it on your computer, and then just it's in between your camera and how you connect to Google Meet or any video, so it streams it. It's great.
Oh, I think I have something to play with today.
So
Yeah.
install it. It's just fun.
So,
Especially when you're talking about robotics, right?
what's that?
Especially when you're talking about robotics, it's
Oh yeah.
timely.
Ron, you always make me feel like I am nowhere near the whole nerd geek realm anymore.
It changes. Different things for different. Yeah.
Oh, he raises the bar all the time.
So I think Lou Ponder some more had a question about where you're based, not an RTX or GPS RTK fix, but Washington. Is that correct?
So I didn't. It doesn't auto scroll.
Oh, yeah.
Where are you based? I'm actually in Redmond. Well, right now I'm in Sammamish, which is just east of Redmond, Washington. So, when COVID first looked like it was going to be a thing, they said, "Why don't you all work from home?" So we've actually been working from home since early March, and I've been surprisingly productive with robotics. It turns out that most ROS work is actually done in simulation, and then you transition to robots. So we can actually do a lot of work on a robot in simulation, testing different algorithms, testing different sensor inputs. A lot of our work is really has been on porting solutions and working with other companies. But we can do a lot of that work in simulation, verify our algorithms or verify our solutions upstream before we actually transition it to a real robot. And that allows you to really separate your concerns. Building the algorithms are hard. Building robots are hard. Trying to isolate whether it's a hardware problem or a software problem is really cuts that problem into two pieces. And allows you to focus on the really narrow down where the problem is. So I encourage people to build simulations as much as possible, and really try and model what the robot would do, because you're not necessarily always in front of your robot interacting with it or have the space to work with it. But if you're in simulation, you can work with it on a laptop, on a train or a bus, and then when you've gotten to a point where you're like, okay, this isn't going to really hit a wall in simulation, let's go try it on a real robot. So there's my pitch for sim.
You got a few of us on board with you on that one. Not everybody though. There's a handful of a group that like to simulate in the real world. Build and iterate and hack and let it crash.
Simulations are doomed to succeed. That is awesome. Can I use that?
David, you'll give him credit, won't you, David?
Yeah, that's actually really awesome.
Yeah.
That Rodney Brooks. Okay. Yeah, every time I bring a robot home, my wife asks me, "What does it do?" Okay, no, I won't. So one of the reasons why Microsoft Robot Studio was shut down is we were actually working on a first-party robot, a Microsoft robot. And we brought this robot into people's homes and we said, look, we built a robot. And they're like, cool, what does it do? And we would say, oh, it does whatever you want it to do. It's a platform. And I want it to do my dishes, do my laundry, vacuum my floors, clean the litter box. It doesn't do any of that. Well, what does it do? Well, it can follow you around and play music, and it has a projector out its rear end. Yeah, it turns out that people don't necessarily have wall space to run, have the robot project on it. So we kind of put that aside and said, well, let's focus on the software and other solutions. So.
Well, cool.
Well, I think I took an hour and a half.
At least, maybe more of that. Or we've taken that much of your Saturday away. But I got to tell you, I think everybody is really grateful for your time, Lou. This has been a very outstanding presentation, and honorary member of both Hackster DFW and DPRG, I'm sure. No objections there. And boy, if there's anything we can do for you, I hope you let us know.
Oh, absolutely. And please do reach out if you have any issues or questions, and post issues if you do hit them. We know it's harder than it should be, and we're actively working to make it easier. But ROS is a skill, and it takes some time to really kind of get into it. So if you're having problems with it, it might not just be you. It might be actually broken.
Yeah, no, it's awesome.
Cool.
Awesome to have support like that, and well, we're really again just really thankful for your support today. So it's awesome.
Absolutely. Unfortunately, I do have to run, so
Yeah.
I'm going to say goodbye, good luck, and stay safe.
Thank you much, Lou. Same
Have
to
a
you.
good
Take
one.
care now. And for
Bye-bye.
anyone who's remaining, thanks again, Lou. Take care then. All right. So, well, that was pretty good. And thanks to Harold, who had to leave, but it was through Harold's connection with Lou, met at a conference or something, that we had the ability to set this up. So, and thanks, Ron, and Hackster for letting us coordinate it in this way. It's really helpful.
It was amazing.
Yeah, it's a lot of topic that we discussed and a lot of great learning.
Tons of ground.
Yeah.
Now, if there's only time that came with it to go dabble and play, but we can delegate to all the retired people. Okay. Hey, so don't want to cut things off, but if anyone does have questions to throw to the club or little challenges or things you want to talk about, this is a good time to do it since we're all on board. I think we're all dried out. That was a lot to absorb.
So I'm thinking so too. That yeah. So probably aim for Tuesday.
Well, cool. So at the moment, we don't have any presentations for DPRG yet for next month. If any ideas come to mind, please do throw them my way or to Doug or John. Other than that, I'm thinking this was so productive. You know, one idea we might have is that if somebody stumbles on a YouTube video of a robot or some kind of topic they find interesting, feel free to send an invite out or ask me, and I'm going to start reaching out to people that have done cool stuff that published it on the web and ask if they'd like to present to the club. Why not? And this seems so effective, and as far as I know, everybody likes it when we're stuck at home this way. So keep those ideas flowing. And aside from that, I know, let's just talk about the calendar. So especially with the way Texas is going, seems it'll be even longer and longer before we can meet in person again. But we're continuing to meet every Tuesday night for the DPRG part of this equation. And it's just a casual, friendly conversation. We talk about what we've been building or working on each week, which was really strong at the start of the COVID thing. And now I think we're running out of gas. We need to re-energize our wheels a little bit at times. Ron, how about Hackster? Do you have some upcoming things, I think, you'd like to mention, everybody?
Yeah, this coming Wednesday, we're going to be talking about NVIDIA stuff. On our Hackster DFW page on our meetup, we have someone from Microsoft, Paul DiCarlo. We'll be talking about computer vision and how you would do machine learning on these NVIDIA devices and how it connects it up to the cloud. So it's posted there. And on the 20th, July 20th, I will be speaking about anomaly detection. So if you're interested in anomaly detection to your IoT application, IoT devices, feel free. It will be on a Monday morning at 11 a.m., I believe, at the Artificial Intelligence in Telecom group meetup. And so I invite you to attend that, and I'll be talking about ML.NET and also anomaly detector, cognitive services, and also related to Azure streaming analytics. So this is where you have your sensor data streaming up to the cloud, and detecting anomalies. So I call it Spidey senses. So adding Spidey senses to your internet application app, in IoT apps.
You have the best presentation titles, Ron.
So just to be
I love that topic, Ron. I mean, the problem that I've always had with that is that latency when it shoots it up to the cloud. I mean, because if you're really honest to gosh, serious about catching, your problems, you don't want to have to find out, like 20 seconds later. So that's something that I always think, isn't there a way that we can do this like on site? And I never see that kind of you can do it this way or you can do it that way. That'd be
one of the things that I was testing it with, a project that I was kind of working on is related to anomaly detection running on the edge devices. So if you have there is a way to run a container application or containers or Docker containers, if you've heard that one, to run these instead of running it in the cloud. They typically gets deployed in the cloud. You can actually run it as a on your local device. So on your gateways, pretty much, the closer it is to the sensors. So your gateway would be maybe running an API that you can access instead of sending the data up to the cloud. But in terms of deployment, you can deploy it from the cloud. You can deploy it from the cloud to the device.
Right. Yeah, I've seen that, and I think that works great. It's only when your models have to evolve because of more data coming in, and unfortunately, the data side is where I come from, career-wise, and so scrubbing the data, taking out any of the anomalies, and then deciding what's an anomaly based off of feedback from your machine. So I've always seen it as a two-phased approach. It's like you've got your current model running on your bot, and at the same time, it's gathering data to be able to batch upload it, and then the cloud side doing a full analysis, hopefully with looking at the models going, do we need to adjust this?
Yes.
Has someone dug a trench? Or, just whatever, things like that. And I do tend to think in terms of the farming stuff because I've kind of been involved in some of that lately. So, yeah, that's kind of why I was thinking about that.
Yeah, so actually, I'm starting to learn more about the anomaly detector. I found out it's a huge field. I mean, there's a lot of algorithms out there. So the stuff that I'll be covering is more related to, as a developer, as someone new, how do you integrate these to your applications, right? Different ways in how you would integrate some kind of anomaly detection without going through the data science, a lot of different, algorithms there. Yeah, but definitely can be expanded into, different algorithms, how you would use it. So.
More like identified standalone QA.
Yeah. Yes, pretty much.
Great. Thanks.
Cool. Well, thanks, Ron. So we put, I copied the links from those into the chat for anyone that would like to attend.
Oh, yeah.
Cool.
And, okay, so let's see. Anything else anyone would like to bring up and chat about yet today? All right, then. So with that, sounds like we've had a pretty good meeting, and I want to thank everyone for attending, and thanks again to Hackster for working this out with us, and I look forward to our next session, hopefully as soon as, what is it, Wednesday the 15th for home security, or Tuesday the 14th for the DFW Builders Night Out, virtual.
Oh, yeah, that reminds me. You see the S. Carlos, he's got S. Carlos Barker, that's my friend Chuck. He ordered one of the robot kits for the Build Your Own Robot for this year. They got canceled.
Oh.
Yeah, and I was thinking, we have the technology to do some really better videos on how to put things together and things like that. And I was kind of wondering, has anybody talked about that?
I haven't heard discussion of it much lately. Doug, who was pulling that course together, has had to leave. I know he's had some kind of personal things which have restricted his time on developing videos and tutorials.
Right.
And that's on top of the issues with COVID that have thrown a wrench in, at a personal level. So I would say if there's questions about that, just reach out to Doug. And, if nothing else, Mary, what we found pretty effective, I think, on Tuesday nights is that people try what they can, and then when they get stuck, doesn't take fancy video or anything, just hold it up to the camera. And we've been helping each other pretty well, even virtually through these meetings on Tuesday nights. So I think we start them every Tuesday night at 7:30, and they've been going on for often 2 hours.
Yeah.
Of just pitching back and forth, and sometimes everybody talks a little bit about their project, and sometimes one person has a cool enough thing that keeps us all really distracted for a half an hour.
Yeah. No, but I was thinking that Tuesday night would be good. Plus, I just recently then purchased Movavi Suite so that I could start learning how to do videos and things like that. And you know me, at that novice level, I'll be the perfect one to try to show somebody, now don't do this, do this. We had such wiring problems the first time we did that. So I don't know how far it'll go. It's taken me a little while to get up to speed on it. I'm just got it. So I was just thinking about that because of all of that. So hopefully I'll be able to contribute some.
Hopefully. Now, David, you've asked if I can unmute your phone number since you're dialed by audio. And unfortunately, with the way Google Meet works, you have to unmute yourself. And I've misplaced the instructions, but if you're on an analog phone, I think like you are, I think there's a *6 or a #6. If you give me a moment, I'll try and find it, but I don't remember what it is offhand. And if somebody else can find that and let Dave know, that would be great.
How about now? You hear me?
We hear you. You got it.
I just did a *6 on my phone.
Memory serves well. Score. Speak. What do you got?
Oh, well, it sounded like you were getting ready to close up, so I had actually just made another video, and I wanted to see if I could stream it to you guys.
Sure. Either put the link in.
How do I become a presenter?
Because you're in here twice, right? You're on your analog landline for audio, and then the D, David, is your laptop, right?
Yeah, it's my desktop now.
So on your desktop, then on the lower right corner, if you move the mouse towards the bottom, a banner should come up, and there should be a little arrow with a box with an arrow in it that says Present Now.
Okay, yes, I see it. I push that button.
Click that button, pick the screen, and the floor is yours. It's a very self-organizing kind of a tool that way. Are you finding the Present Now and Share window feature?
It's asking me window or screen to share, and I said entire screen, allow, and it says only share screens of sites you trust. So I guess I have to trust you guys.
You do. You better trust us. Now you got it. You are presenting. It's coming up.
And do you see a video?
It is not quite there. It is. RCAT 30 May, measuring and correcting odometry drift using stereo sonar in a corner.
That's it.
Score.
I'm going to try to play this and see if it plays.
Yep, we'll see.
It seems pretty blocky. So here's my odometry test. If the video works, get in a corner and measure. I know where I am. Measure the distance to the two walls. Then do something for a while and come back and measure that again and correct the accumulated error. And for this test, it's basically a similar test to the one I showed at last month's meeting, where the task is to just do perimeter following for a few minutes. I put it inside a 30-foot by 40-foot virtual boundary. Yeah, this is not working. It's not playing. It's skipping.
David, I'm thinking that what's actually must be going on is that Google Meet is probably having to mix all these crazy video channels and or something between that and network latency.
Okay, so I think my experiment, the answer is no, this does not work.
At least not with that method. There may be some other methods, but
I suspect that the problem is you need to pick a window with the video and not the whole screen.
that might work better.
Okay, how do I do that, John?
Stop presenting.
Okay,
Stop
hang on.
presenting, and then instead of presenting the entire screen, yeah, so go same place where you started presenting, and yeah, that's it. Stop presenting, and then yep, that's it. And now go
Okay.
back down to the same thing. Start presenting, but this time pick a screen. I mean, pick a window instead of the screen. So pick your VLC player.
Okay.
Or Clay posted a question of, could you just post a link of it?
Yes, I can.
Because that could be a nice backup. But if one last experiment here, if you just try and present the VLC player.
Okay, I did that. Suddenly it went away.
And well, we see your video, but it's stuck. If you hit play,
Play.
and
Still the same.
is it just as choppy as ever?
Well, let me get it a little further. I've got something up here that says, will you allow Google Meet to send notifications? And when I say no, it just comes back and asks me again. Do I
I
have to
can't
say-
help you.
Yeah,
So-
no, it's still jerky.
It's still choppy. So it looks to me like we'd probably have to drop the resolution if you wanted to stream it. And who knows if it's the network or Google Meet or your desktop, who knows?
Let me try that then. Here's a low resolution. Hang on. There it is. Is that any better?
We got the orange traffic cone.
Well, it's playing faster on my screen.
Yeah, so David, you know what we could do is, if you want, maybe like you and I could practice during the week or something and try and find a
Okay.
process that works.
Is this working?
It is not working, at least for me.
It is not.
No, and
You don't-
Mary's shaking her head as well.
Okay.
And Clay's wondering if everyone would mute their video feed. So I'm going to just suggest that we experiment offline. And
Or else we can try this on a Tuesday.
yeah, on a Tuesday night. So we can let people get on with their Saturdays.
Sounds good.
Okay, but if you have a link, send it along, David, and if you want, we'll pick a time during the week and we can sort out a process, because it'd be a cool capability to have, but there's too many moving parts to make everything work right all the time. Okay, all right. Well, last call then. Anyone else have something to display or ask or show? Cool. Well, with that, I'm going to stop the recording. And once again, thanks everybody for joining. And